Okay, good afternoon everyone. I hope you're doing well. So let me share my screen and then I'll get started. Okay, so as you know, unfortunately, we are not going to meet face to face for the remainder of the semester, but we'll be meeting every Tuesday during our lab time. We're going to meet virtually and you're going to complete the lab. So before that, we're going to provide you the experimental data which you could have generated if you met face to face, but we are not going to meet. So for example, for today, and there is so before that you must know that probably some of you already submitted. I saw the investigation 2 lab report that is due tonight. Okay, if you have any questions, I'll be happy to explain. You can unmute and ask me a question if you have any questions. If not, I'm going to go over the preLab experiment 3, investigation 3. So that we are not doing any actual lab calculation, but this was very important because it used to be part of your final lab practical. So we'll see how it will work out on the final, but no matter what, you will be doing some calculation involving this experiment. Okay, so make sure that you understand how to do the calculation. Also, always you're going to see questions on 1150 final. Okay, so this tridation lab is very important for both 1150 and 1151. Before you get started, so again, I'm going to remind you and I'm going to send you an email that next meeting is going to be Tuesday at 11. It may take more than 2 hours. It may take 2 hours 50 minutes, the entire time. But basically, you will be doing same thing what you could do in the lab, except you are not going to have any hands-on to generate the data. So we're going to provide you the data. Still, you will be presenting in a group, and I'm going to set up the group in Canvas. You will be getting emails from me, probably today or tomorrow. So I'm going to set up the groups, and in a group, again, there will be one group leader, but you'll be working and making PowerPoint presentation. But before that, based on the data provided to you, you'll be doing the calculation, then have some discussions in a group, which will be assigned automatically again by the Canvas. And I will go over again if it is necessary. But I haven't yet set up, so that's why you probably don't see the group number and your group lab partners. You haven't yet seen, but you will be able to see everything. And then we're going to meet virtually. Again, we're going to meet using webEx in Canvas, and you will be seeing the groups. And then you can have some discussion within a group, and I'll monitor the groups. And I'll participate if you need some help. So this part will be done later, so I'm not going to spend too much time. Okay? But you'll be doing basically the same thing what you could do in a face-to-face lab meeting. Okay? Except the generating the data by doing some experiment. So we're going to provide the data. So this week we missed Tuesday's lab, but we're going to do the calculations. So you need to complete. And I know this is due tonight, but I'm flexible. Okay, anytime. If you need some more time, I'm happy to extend the deadline. So don't worry about that. But you need to notify me. Okay. I think it would be better off if you can finish by today. But if not, I will accept until tomorrow. And then I'm going to show you. Already I posted the data which you could do in the lab. So then I'm going to show you how to use the data. So step by step. First thing you need to know the meaning of the term tide descent. What does it mean? Tide descent means whenever you have something unknown and especially solution. Okay? Like if I have a unknown milk, what is the percent of fat in the milk? Okay? If I have unknown blood sample, what is the percent of some antibodies in the blood? If I have a saline solution, what is the percent of glucose? For example, in DW5, okay? So, tide descent means you use a technique to find out the unknown, okay? So, what is the meaning of the term standardization? Similar, standardization means to make it known. And here we are using tide descent technique to make it known, to standardize. What are you going to standardize? A solution of NaOH. Okay. So again, three terminologies. You're going to use tide descent to standardize something. That means that standardize means to make it known that can be used later for different purposes. Okay. It takes some time. Like I have a standard sample for blood analysis. I can use that one to know the unknown amount of different proteins in a blood. So this is how instrumentation work. Without standardized data, you cannot figure out what is the unknown. Okay, you need to have a reference. So the reference is going to be this. So how do you make the reference and standardize it? You make a solution and then you can standardize it. So how do you standardize? Again, I can make this one known using another known. Otherwise, you cannot do that. Okay? So this is going to be known in this tradition. So what is this? This is called KHP. KHP. Potassium, hydrogen, phthalate. Okay? So it's a potassium salt. Because you'll be doing in water, it has to be soluble in water. So that's why you use a potassium salt of phthalic acid. But it's a monoprotonated. That means it has only one proton. So this will act. This is an acid. And this is a base. This is a base. So what are you going to do? Acid-base traditions. To make something known if it is unknown. So what is unknown? This is unknown. This is unknown. And this is known. Okay. So if I know the reaction, KHP reacts with sodium hydroxide to make salt plus water, always. Whenever you do acid-base tradition reaction, and if the question asks, what is the net ionic equation for an acid-base tradition? So we'll see the acid-base tradition always 1H plus what? React with 1 OH minus to make 1 water. Always. It doesn't matter whether it's a monoprotic, diprotic, triprotic or polyprotic. What does it mean? So here, this is monoprotic because it can generate only 1 H plus. But I can have H2SO4 which can generate 2 H plus SO4 2 minus. I can have H3PO4 which can generate 3H plus phosphate. Okay. So this is key when you do the tradition. How many protons are going to be generated by one formula unit? Okay. So here if this is balanced, that means this is 1 to 1. 1 H plus reacts with 1 OH minus. Okay. Always. But if I have something else like calcium hydroxide, then I need to balance it, okay, which we are going to discuss later if it is necessary, but you must know for your 1150. So how you're going to titrate? So basically we take 3 or 4 flasks, and you have the KHP, known amount of KHP in each flask, okay. Then you dissolve, you add water into each one. How much water? Doesn't matter. But the procedure says around 50. Now if I take 55, is going to be any difference? No. So when I teach 1150, then I give the analogy and students love it. So for example, and this is a perfect analogy I can give you. Always we give analogies to understand something which are invisible or very tiny, we cannot see. We cannot see protons, we cannot see hydroxyl ion, we cannot see potassium ion. They're so tiny. So some real world example helps to visualize and to see what happens in the molecular level. So this is the example I give in my class. Let's assume that you have fish bowl and you have many fish there. And the number of fish is the moles. Okay. So when you quantify something, you need to know the number of moles. Okay. If I add more water, do you think the number of fish will change? No. If I remove water, number of fish will be the same. Same thing, the KHP, number of formula would be the same. Doesn't matter how much water you put in there. So why you need to use around 50? Because you have to make it dissolve. Otherwise you won't be able to titrate the entire amount of the KHP. So whatever the amount you need, that amount you need to add to make it completely dissolve. That's all. It could be 45, it could be 50, it could be 55, but you don't want to take too much because you need to keep some room here for the titrate, which is the NaOH base, this one. Okay? Because NaOH is going to react with the KHP to make a salt and the water. Okay? So how do I know that when these two are the same? That is called equivalence point. When these two are the same, equivalence point, many name, or it's called end point. Okay, all are the same. Again, your goal is to make these two numbers the same. Number of OH plus is equal to number of OH minus. But how do I know? In molecular level, you don't see them. You cannot count them. And that's why I go by the mole. But we have many different techniques to know when these two numbers are close to each other. And one of them is called indicator. It's an organic molecule. The color will change depending on which one. If I have more OH minus, it will be one color. If I have more OH minus, it will be another color. So that is your goal. So by looking at the color change, you can tell that you have equal amount of the H plus and OH minus. That is called end point or equivalence point. So here you add, so you have the KHP here, and then you add NaOH from the burette. So this is, by the way, this is called burette. This is burette. And then, so you started the initial volume, you know the VI. And then after adding, you're going to look at when the color change takes place. So you added that much. That is the final volume. So VF. That means this much amount was required to titrate to get an endpoint. Now this is actually too dark. Your goal is to get lightest possible color. Too dark means you overshoot. You added a little bit more than what was required. Okay, that's why you see too dark. But in the real world, when you do the experiment, then you could see it is not difficult, but it takes some time to understand, because you have to use drop by drop at the end to get lightest possible pink color, which is the color due to the phenolphthalein indicator. Okay, so how much base was used to get the endpoint? So the volume of the base was final volume minus initial volume. So if I know the volume, I know the number of moles. And if I know the moles and the volume, I can calculate the molarity of the NaOH. So that's the standardization of NaOH, means what is the molarity of NaOH in the solution. Okay, so that's your goal. So how do you do it? So you take the KHP here, known KHP. That means I know the moles of KHP. Moles of KHP. Then you know the NaOH, how much NaOH was required to get the very faint pink color. If I know the volume of the NaOH, and from the equation I know the moles of NaOH equals moles of the KHP from the equation, 1-to-1 ratio. It may not be 1-to-1 because you are using monoprotic acid, that's why it's 1-to-1. So once you know the moles, the molarity is going to be moles divided by volume in liter. That is the molarity. Then you can easily calculate what is the molarity of the unknown NaOH solution. So you are not going to do the experiment, but you will be provided the data. So again, how do you calculate? As I said, the equation is very important. 1-to-1. That means moles of NaOH must be equals to moles of KHP. Okay, that is KHP. This is the formula. If these two are the same, then you can get the endpoint, which you're going to get from the buried data. So final minus initial is going to give you the volume to get the endpoint. If I use this, by the way, you are going to use about 1.00 gram, that will be given. So I have to know how many moles of KHP I had. So grams divided by, you have the grams divided by grams in 1 mole is going to give you the moles of KHP. If I know the moles of KHP from the equation, I know the moles of KHP is equal to the moles of the NaOH because they react 1-to-1. 1-to-1. Okay. You can stop me anytime, okay? This is very critical. And I believe if you understand this, you are going to do very well in your 1150 final exam also. Okay? You're going to see always there will be one question related to titration. How do you titrate? Okay? For some reason, some students do not get it, but this is not difficult. If you have any doubt, I'll be happy to explain. The difficult part is we cannot see the molecules, so tiny. That's why you have to imagine what is happening in the molecular level, who are the reactants, and what mole ratio can give you. That means what information you can get from the mole ratio so that you can calculate the molarity of the unknown. Now in this case, unknown is the NaOH, but unknown could be acid. I could take one acid, for example, I can take NaOH and then I can take HCl. Same reaction. If this is standardized, that means this is known. after the KHP experiment. Then if someone gave you unknown solution of HCl, you can tell the molarity of the HCl. Easily you can tell. I can have a diprotic, I can have NaOH, standard NaOH, then I can take H2SO4. I can calculate what is the molarity of H2SO4. Or I can calculate what is the molarity of phosphoric acid. Or in the final exam, which probably you're not going to do hands-on, what do you use to give? Vinegar. What is the molarity of vinegar, which is HCH3COO? Or I can write, it depends on the book, different way. Or I can write CH3COOH. What is the molarity of this? But doesn't matter what is the acid. If I know this, I can calculate this one. Because I know they reacts by the number, which is mole. And from the equation, I know how many molecules, acid molecules, are reacting with how many base molecules, or the formula in it. That's all. So if I know the moles, I know the volume from the burette. So what was the volume? Volumes was V in final minus V initial. But you need to divide by 1000 because I need volume in liter. So these were a milliliter. These were a milliliter. So when I divide by another 1 liter, then I will get in liter. So then I am going to get in liter. Whatever the answer you get in liter. Okay. This is how you do the calculus. Okay. So whatever the moles you get, you divide by the volume in liter, and this will come from the burette. Final minus initial period reading. Okay. It's not difficult. But so I'm going to show you. So if you watch the video, you know all the experiment data. How did you collect the data? Now this is one of the quiz question. Okay. You need to complete by tonight. Okay. So there are 3 questions. These are very simple. Assume that you have taken 1.085 grams of KHP. So you are doing the additions. And you have KHP, which is 1.085 grams KHP. In chemistry, you cannot do anything in grams. Always. No matter which class you're taking, because the molecules, in the molecular world, molecules react by the number. So if someone say, hey, I have 1 gram of a tablet, and someone else say, hey, I have 10 milligram, I don't know which dose is higher, because I don't know what are the molecules. Molecules react by the number. So if you have a higher mass, and you have a very, very large molecule, the molarity could be probably, the moles could be lower probably. We don't know. So whenever you are giving grams in chemistry, grams of KHP, I know I cannot do any calculation unless I know the moles of KHP. So this is the first. And that's why I'm giving how many moles. That is the first quiz. Because without the moles, you cannot do anything in the chemical world. Okay. So how do you go from grams to mole? Then I have to cancel out the grams. So grams of KHT has to be on the bottom. What should be on the top? Moles of KHP. Then these two are cancelled out. You are going to get the moles of KHP. And you are giving the molar mass. So 1 mole means 204.23 grams of KHP. How many grams did you take? 1.085 grams. Okay. So then I will plug into my calculator, and then I will have the answer. What is the answer? That you need to use you need to find out using your calculator. Now, common mistake, the significant figure. So this is a division. What are the rules for division? The number of significant figure should be the fewest as in the measurement. So how many sig fig you have here? 4 sig fig. How many sig fig you have here? 5 sig fig. So the answer, this one should have 4 sig fig. Okay. Last time I didn't get a chance. So some of you got wrong. I didn't deduct point because I thought it was all about learning. So if I have 0.023050 grams, okay, how many sig figs are there? Anyone? You can type in, or let me see if I can see, or you can unmute yourself.
5.
5. Okay, anyone else? Okay, so the rule says that these zeros are never significant at the beginning. The middle zeros are always significant, always significant. And the trailing zeros depend on the decimal. Because I have the decimal place, this is significant. So yes, 1, 2, 3, 4, 5. If I have 200 grams, how many significant figures are there? Anyone? One. Okay, this is the hardest part. This is the hardest part. Okay. Now, if you think that it should not have 1 sig fig, it should have at least 2, then you do not write this way. If I know it should have 3 sig fig, then I'm going to put a dot at the end. Then it will have 3 sig fig. Without the decimal place, you cannot count the trailing zeros because these are just for estimate. Okay. So, this is how you're going to get the answer for this first quiz question. Any question? Next one. So again, you can see step by step towards the goal, we are trying to do the calculation. So now it says if you have these many moles of KHP. So from the previous experiment, previous quiz question, you know how to calculate the moles. And you are giving the volume from the burette. Now again, here you are giving the V equals V final minus V initial. Okay. You are giving here this one, this. But it could be only, you could be giving the both. Then you have to subtract to see how much NaOH was used to get the endpoint. But you are giving in milliliter. We know molarity equals moles divided by volume in liter. So I have to convert this to liter. So if I am giving 18.26 milliliter, that is going to be 18.26 divided by 1000 liter. Okay. That means 0.01826 liter. Okay, that is the first thing you need to do. If you practice, you do not have to do all the setup. When you do the calculation, you can just plug in this number. You just use the decimal place. You just move to 3 places. So if I move 1, 2, 3, means you are dividing by 1000. Okay. If I multiply, then I'll move to the right. When you divide, and that's why the decimal system is so popular and so easy for the scientist to do the calculation. In day-to-day life, we use different system and that is very difficult. So this is called metric system. So I know the volume and I know the moles. So what will be the molarity? Again, molarity is going to be moles divided by volume in liter. And moles I know 3.505 times 10 to the negative 3 divided by 0.01826. That is going to be the molarity. And which is the unit, capital M. Okay. Later on we will be learning because this is a confusion for 11-20 student. Most of the 11-20 student, they don't understand the difference between lowercase m, uppercase m, and more. Okay, you must know this. Otherwise, it will be very confusing when you go to the next class, 11-16. Okay. Can anyone tell what is the lowercase m? You don't know yet. Okay, so that don't worry if you get wrong. If you have taken AP chemistry, maybe you know. Otherwise, you don't know. Okay. Has anyone taken AP chemistry? Probably not. Okay, so you'll learn it there later on. That is called molality. This is called molarity, and this is the mole. Okay, which is number of particles. Okay, again, you are going to learn the difference between these two in 11-60. Okay, so I don't want to go over. Do you have any questions? So then you have the answer. What is the molarity? Okay, which is capital M. So you plug in, and then you will get the answer. But you have to use the significant figure rule. So how many significant figures are there? 1, 2, 3, 4. Here 1, 2, 3, 4. So the answer should have 4 sig fig. 4 sig fig. Okay. When you use your calculator for the power of 10, you never use the power of 10. Okay, otherwise it could be confusing. What I do, 3.505 divided by 0.01826. And then I'm going to keep times 10 to the negative 3 as it is. Then manually you will be better off. And there is no way you can do mistake if you know how do you do mentally by changing the number of zeros, decimal point between them. Okay. So anyway, so you'll get the answer here. So this is your second quiz. And the third quiz is very simple. If you understood the tradition, you know what is the third quiz. Okay. Any questions? Then I posted this one. You should have done this one because of COVID, we are right now not meeting. Otherwise, last Tuesday you could be doing this one. Okay. So I'm going to show you. I posted the data. You need to use the data, and then you need to complete this fillable worksheet. So how do you complete? So in the actual lab, you could have done 3 or 4 trial. Trial 1, trial 2, trial 3, trial 4. At the beginning, you're going to write the final volume. But you don't know final. So you need to set up the burette first. You have the burette. And you have, let's assume that at the beginning you have 0.50. So I'm going to write 0.50. Okay, that's the beginning. You're going to write. Then you do the titration. So you have the flask here. And then final VF. So now you have the pink color, light pink color. Okay, you're going to look at what is the color. So what is the final? Let's assume that I have 16.90. Okay. For burette, you read top down. 0 start here. 0 start here. And the bottom you have 50.0. And because the smallest division between the marking is 0.1. So you have 0.1, 0.2. And 1/10 of the 0.1 means 2 decimal places. You must report the burette reading with 2 decimal places. So I have 16.90. The final. That is the final. VF. And this is VI, initial. What is the volume used? So this, if I subtract these two, 16.90 minus 0.50 is going to be 16.40. So this goes 16.40. Okay. But I'm going to provide the data and you will see it has been posted. So if I have this one, then 2 decimal places, 2 decimal 2. So this is correct. 2 decimal places is correct. and the grams. What is the gram? That would be, let's assume that I took 1.000 grams KHP. Okay, how many moles? Divide by molar mass, which is 243.23, I believe, or 240.23. We just did. Let me see what is the number. 204.23. Okay, 204.23. So whatever the number you get here, that goes here. Okay. Number of, no, so first is grams, the moles, it goes here. Let me see. It goes here. And here it is 1.000 gram. Okay. So I know the number of moles. So the number of moles of KHP, moles KHP equals moles NaOH from the equation 1:1 ratio. Molarity, how to get the molarity? So whatever the moles you get, whatever the number here, this divided by 16.40. In liter, that means I'm going to do 0.01640. But you're going to write only the answer. Okay, so sample calculation, again, this is the common mistake. You forget to put. How do you get? So first I'm going to write VF minus VI equals V. And then V divided by 1000 equals VL. Then I'm going to write 1.000 grams divided by 204.23 moles KHP equals the same amount of the moles of NaOH. Okay. Then you're going to do molarity of NaOH equals moles of NaOH divided by VL, whatever the VL you get. And then you write the answer. So you're going to show only one sample calculation here, only one. Sample means only one set. But you're going to do 1, 2, 3, 4 sets. Okay, 3 or 4. You can take 3, best of 3. Then so that means you're going to get okay, so here it says light pink, so I'm going to write here light pink. Okay, then I'm done with this set. I'm going to do the same thing for the set number 2. Then I'm going to get M2. Set number 3 is going to give M3. Set number 4 is going to give M4. So what will be the average? So the average molarity is going to be M1 plus M2 plus M3 plus M4 divided by 4. I notice some of you, when I write like this, some of you just copy exactly. No, you don't want to do. You are going to put the value. I'm assuming already you know the formula. This is just the formula. You don't want to write M1 plus M2 plus M3. You're going to write whatever the value M1 for M1, value for M2, value for M3, and value for M4. Then you divide by 4. So if this one has 4 sig fig, the answer should have 4 sig fig. Okay, on your average. How do you get the range? So again, you're going to have 4 data, M1 values. So highest minus lowest. You do not have to write highest minus lowest. You're going to write the highest value, whatever the like. So if I have 0.3940 minus 0.3780, something like that. And that is going to be, and then you write the answer, whatever the answer. Then you are done. Okay. Any question so far? This is how you complete the worksheet. Okay, so I posted the worksheet, which is this. You're going to see like this. Okay, that you could generate in the lab, but unfortunately you didn't have a chance. So someone generated for you, and you are going to use that data to complete the calculation and fill in this data table, the fillable data set. Okay? You download the PDF file, you upload, and then you enter the values, and then you upload. Okay? And if you, whatever I showed, if you complete all with correct number of sig, you are going to get perfect score. Okay? I'm very lenient. If you do one mistake, I don't deduct point. But if you do same mistake again and again, I need to show you and maybe deduct a point or so. Okay? But I try to avoid if it is very, silly mistake. Okay? So this is how you're going to complete. Now this I believe this is due tomorrow, but again I'm lenient. You just tell me it won't take more than 20-30 minutes. So why waiting? If you know how to do it, I just showed you. You just spend another 30 minutes and do it now, today. Then we'll be done. You will have plenty of time to do other things. I know you are taking other classes as well. Okay? Tell me, do you have any questions? I'll be happy to answer your question. Let me see.
I have a question.
Okay.
So is this the data that we're supposed to copy to use?
No,
Right.
this is just a sample I gave you. And the data, what you will be using, that has been posted in Canvas.
Okay, so it's already been posted.
Yes.
So,
Yeah.
okay.
Very similar. There are only few points. So just to see the difference between the students and different sections. So every section is going to get different data. Okay. This is just an example. Okay. Otherwise, I know you understood, you are going to do very well, but sometimes we have a tendency to copy everything. You don't want to copy exactly. Okay. But it would be very similar. Even the sig figs, I know sig figs are exactly the same, but instead of 12.5, maybe you will see 14.5, okay, and so on. That means you have to do the calculation, and you have to enter the values in your calculator and use this correct number of significant figure. Okay, that's all. Yeah, it's very simple. Any other questions?
Yeah, I have a question.
Okay.
So there's two charts on the pre-lab. Are we just doing the first chart? Like there's two different tables.
There is only one. Let me show you. Can I see the screen?
Yes.
Okay. So, if you look at the investigation, okay, so this one I posted today. You see, so first you're going to watch. You do not have to, but this is the theory PowerPoint presentation, but I explained to you. But you need to watch this one, okay? And then after watching this, based on this, so there are quiz question, and I went over the quiz question today, okay? So you're going to complete that one, okay? That is the first thing. Then, as if you are in the lab and you collected the data. So this is the data you're going to use. And you're going to fill this one, okay? But you are not, this is not fillable. This is the data. You are going to use this data to fill this table, okay? Is that clear to you?
Yes, so like in my pre-lab, like when I click on the preLab3 fillable worksheet, there's two separate tables.
I'm sorry, I cannot hear you. Your voice is cutting off.
Can you hear me now?
He's saying there's two separate tables on the worksheet fillable instead of one. So do we have to fill out both?
Can you show me where?
So go to the preLab3 worksheet fillable.
Okay.
Click on that, and then it
This one?
yeah, that one.
Okay. Where do you see to?
And then download it. Like click on the link.
Yeah.
Okay, and then pull that up.
Okay.
All right, and then scroll down. There's 2.
Okay. So no, okay, now I got it. Okay, so this is from the actual lab manual. So sometimes what happens, students work in groups of 4, and that's why 4 column is not enough. You need to have 8 columns. So then you combine these 2. No, but for you, you're going to do only 1. Okay. Now I got it. Now I got it. Okay, I didn't pay attention. Okay, so basically this is copied from the lab manual. That's why you see that in lab manual there are 2 sheets, because you're supposed to do in the groups. As a result, 4 column was not enough. So you see basically everything is duplicated in the next line. So instead of 4, so we sometimes groups of 2 will fill this first page, and another groups of 2 will fill the second page, and then they're going to combine. No, you're not going to fill out both. You're going to fill out only first page. Okay. Okay, I didn't pay attention. Okay, thank. That was a good question. I didn't know that even there are 2 pages. I didn't look at the second page. Okay, any other questions? If no other questions, then we're going to meet 11 o'clock on Tuesday, regular time, lab time. And I will give you the data, what you'll be using, and I'm going to explain. Okay, so we'll have 2 hours 50 minutes. We do not have to before. Even if you need some explanation, first 30 minutes to 1 hour I can use to explain how you're going to do it, how we're going to do the presentations in groups. So you'll be seeing the assignment in Canvas, group assignment. Now I can do randomly, or if I can let you pick your lab partner. Either way, I'm fine. But right now I believe it is going to be randomized. But if you have any choice, I'll be happy to manually add those. You can send me an email. Okay. So that's all for today. I'll see you then on Tuesday. And if you need any extension, I'll be happy to extend today's assignment until tomorrow. Okay. Just send me an email. Okay. Okay. So that's all for today.